Hi viewers, welcome to the Junior Astrophysicist. This is Akash, and in this video we're going to be looking at wave interference patterns. So, as we know that light forms an interference pattern, we should also understand how the interference pattern is caused by the waves of light. So let's see that in today's video. Let's begin. So yes, now if this is what a wave looks like, it's a simple wave. Let's label this wave. So this top part is what you call the crest, C-R-E-S-T, and this bottom part is what you call the trough, T-R-O-U-G-H, trough, and this part is called the amplitude. It's A-M-P-L-I-T-U-D-E. It's called the amplitude. So this is basically what a wave looks like. So waves are the same for all electromagnetic waves, sound waves, and any kind of wave it is. Maybe light or sound or any wave. It can be a gamma wave or an alpha wave, it can be anything. So now let's see how interference occurs in waves. Now in wave interference we have two types. We have constructive interference and we have destructive interference. So now let's look at constructive interference. So in constructive interference, we're going to have two waves coming from two sides. Now, if this is wave number one, like I'm just drawing a simple wave. This is wave one, and this is wave two. Okay, I don't know if it really looks like a wave, but it's somewhat like what a wave looks like. So this is one of the most common pattern of waves. So this is wave number one and this is wave number two. So interference happens like this. These two waves combine with each other and interfere with each other to form another wave. So in constructive interference, you have a positive wave, which means that like this part is positive, the amplitude is positive, and when it goes like this, your amplitude is negative. So you're forming a positive amplitude in constructive interference. So let's see what the interference pattern is like. Now, this wave has a direction to the left, and this wave has a direction to the right. Now, these both waves are going to merge into each other, forming another big wave. Let's see how that is. So this is how interference works. There are like multiple waves which join each other and interfere to form another wave. So when these two waves come together, you're gonna have a bigger wave. You're gonna have a bit bigger one. So this is what the constructive interference is. If you want me to make it more simpler, we can work with like one wave on one side and another wave on the other side. So it'll be very, very easy to understand. But then if you understand that, this is gonna be nothing. So yeah, this is what it is. So we're gonna have one wave here and another wave here. This is going to this direction and this is going to this direction. So you can see these two waves, okay? So what happens is when these two merge over here, it's gonna form a bigger wave. So it kind of looks like this. So now we saw that those two waves were actually only a bit of a high amplitude. Now it brings up a bigger wave. Somewhere like at such a high amplitude. You see? So this is what you call constructive interference. Now let's try to work the constructive interference with values. Let's try to find out what the amplitude value of this wave is going to be. So we can work it out like this. Just erase the whole board so that we can have more space to work it out. Now if this is wave number one, and this has an amplitude of 3. And if this is wave number 2, and this has an amplitude of 2. Okay? So when it interferes and has a constructive interference pattern, you're going to have a bigger wave with an amplitude of 5. Get it? So 3 plus 2 is equal to 5. This is how it works in constructive interference. Now we shall look at destructive interference. Let's begin. So as we saw in constructive interference, a bigger wave is formed with a positive amplitude. But in destructive interference, you're going to have a negative amplitude. So destructive interference works only in a certain pattern, which is like if you have one wave like this, okay, and another wave like this. Okay, so this is a like what do you say? You can consider it as a mirror image where the amplitude is negative here and it's positive here. So in this kind of situation, you're having destructive interference. So if you have learned in math about integers, you would say that when you have combined a positive and a negative integer, you are bound to get a negative integer. This is the same rule in destructive interference. So what happens is now I'm having a negative amplitude and a positive amplitude. And if this value is 2 and if this value is 4, what's going to happen is we're going to have 4 minus 2. Or we're going to have something like this. Because since our positive amplitude is high than the negative amplitude, we're going to have this kind of amplitude with 2. Because this is 4 minus 2. Okay, so it's 2. So I think you would have understood like how the destructive interference pattern works and how the constructive interference pattern works. And now we shall see what is phase difference. So phase difference can be considered like what we just saw as the amplitude, what do you say? This thing, the distance of the amplitude inside the wave. So something like this. This value can also be said as the phase difference. I'll just go into a bit detail of phase difference now so we can get a better idea of that certain topic. Now, if we're having such like this, if we're having something like this, wave like this, and now we're having another wave like this in the same pattern. Don't change the pattern. Okay, and if we're labeling this point X and this point X in a line, okay, just sorry if I had missed the line. It's all the same parts. Now, in this kind of situation, if you're doing, if you have one over here and one over here, you're gonna have 1 minus 1, which is equal to 0 degrees, which is your phase difference. So in this kind of situation, when all your values are equal, you don't even have to calculate. You can just say that phase difference is equal to 0. Okay. So now let's check when the positions are a bit different. So if all of these are aligned together in a very certain pattern, then you're gonna have something which says phase difference is equal to 0 degrees. Now let's see what's gonna happen if you're gonna have a pattern which is not in alignment, but it's a bit different. Let's see what phase difference you'll get in that kind of situation. So when you're having it like that, it depends on the values you have. Now, I'm just going to take a very simple example for you so that you can understand better. So let's draw the wave like this. Now, if this is wave number 1, it's a very simple wave pattern, and this is wave number 2. Okay, oh wait a minute, I'm sorry. It's in the same alignment. Sometimes it's actually a bit tough. Should work on it. Drawing waves is one of the toughest stuff. Now, in this kind of situation, imagine that I have 10 over here, and 10 over here, and 10 over here, and 10 over here. And I'm at 20, 20, 20, 20. So at this kind of situation, what you do is you do 20 minus 10. Or it's actually supposed to be like this, 20 here, and 20 here, and 10 here, 10 here, 10 here. This is actually most detailed one you can get. So in this kind of situation, you have such an alignment, you have 20 and 10, 20 and 10, and 20 and 10. So what you do is, to find the phase difference, you do 20 minus 10 degrees. Both are in degree values. So you're going to get 10 degrees as your phase difference. So this is phase difference. So in this video, I'm sure you would have learned what is constructive interference, destructive interference, and phase difference. So don't forget to like, share, and subscribe to the Junior Astrophysicist. So enjoy learning and have fun. Bye!